Good morning, student. Today we are going to see chapter number 2. Okay, we'll see second chapter, physical quantities and measurement. Now let's see the physical concept, density. Okay, we know that each body has its own mass as well as it has a specific volume, right? As the mass of the body increases, we find that the volume of the body also increases. And as the volume of the body increases, then mass of the body also increases. Means we can say that the mass and the volume of a body is mutually dependent and they are directly proportional. As the mass of the body increases, we find volume of the body also increases. As the volume of the body increases, then we find mass of the body also increases. So let's see the first topic, density. Each body has its specific mass and definite volume, right? As the mass of the body increases, then we find volume of the body also increases. And volume of body increases, then we find mass of the body increases. That is, mass is directly proportional to volume, or I can say volume is directly proportional to mass. Okay, now let's see a note. So note number 1. We know that the different substances having equal masses have different volume. Again, different substances having equal mass. Okay? Different substances having equal mass have different volume. Okay, now let's take an example of the two substances. For example, volume of the cotton is greater than the volume of the lead, or you can say iron ore. Okay, that is, I can say, means if masses of both the substances are equal. If masses of both substances are equal, then I can say that lead is more denser than the cotton. If masses of both substances equal, here only given that, okay, then volume of the cotton is more than the volume of the lead, and it implies lead is more denser than cotton. Now you know this word denser means. What do you mean by density? If a 1 meter cube of volume of the substance is, then the molecules of the substance are densely packed in this volume as much as it is possible. So we want a mass content in a specific volume of the substance. If more and more mass content in a same substance, then we can say density of that substance is more. I can give an example. If say this is an iron block, okay, which is empty one, say, because it is in cubical form. If you are putting a cotton in it, You are pressing it and again putting the cotton, again putting the cotton. Now initially it will get filled with the cotton also, बराबर है? तो उसका जो वॉल्यूम था उतना ही वॉल्यूम तो उधर आ गया है. But what we are doing, we are again putting a cotton in it. So what we find, the mass of the substance goes on increasing. And how it is possible? The air which is inside the gap of the particles of the substance, or say cotton, removed out when we are pressing it. And because of that, the particles of the cotton comes near to each other. Means there is a force of attraction between those cottons more. And the space between, we find that when we are pressing this cotton inside this box, then the particles of the cotton come closer. Means the space between these molecules decreases, and due to that it becomes more denser. Okay? So if the different substances having an equal mass taken, then they have a different volume. We can take an example of 1 kg of the cotton with 1 kg of the lead. Then we find that masses in both of the substances have a same mass, but still the volume of the cotton is more than the volume of the lead. And we suggest us that even if the masses are same but difference in the volume, we find that the densities of these two substances are different. What can we say about the density? We can say that the lead is more denser than the cotton. Lead is more denser than the cotton. Second point to be noted, if the volume of the different substances are equal, then we find that their masses are different. Okay? If the different substances having the same volume, if different substances are in same volume, then we find their masses are different. Okay? Now if I take a 1 meter cube of cotton and 1 meter cube of lead again, then a 1 meter cube volume, in a 1 meter cube volume, the cotton, if we settle, then the mass of that cotton is definitely lesser than the lead put into the 1 meter cube of volume. Means, first point is that the different substances having equal masses have a different volume, and second point is that the different substances of equal volume have a different masses. Here you can say, example, mass of iron is greater than mass of wood, and I can say that this iron is denser, okay, than wood. Iron is denser than wood. Okay? So the question arises, what does density means? So let's see the definition of density. What is density then? Density is nothing but mass per unit volume. Mass per unit volume. Okay? Density means what? Mass per unit volume. I can write this. Actually, density is denoted by C. So here I can write E is equal to mass upon volume. Let's say about SI unit. SI unit of mass is kg, while SI unit of volume is meter cube. If we talk about the CGS unit, then CGS unit of mass is gram, while CGS unit of volume is centimeter cube. Okay? Now let's see what is the relation. Relation between SI and CGS unit of density. Now we know that SI unit is 1 kg per 1 meter cube. I can write this 1 kg as 1000 gram and 1 meter as 100 centimeter and bracket cube. It means 1000 gram upon cube means 100 into 100 into 100. 1, 2, 3. 1, 2, 3 cancel. So what I get? I get 1 upon this 2 zeros and 1 zero, say 1000 gram per centimeter cube, which is 1 kg per 1 meter cube. So this relation we got. Okay, and this is nothing but a relation between SI unit of density and CGS unit of density. Now let's see an example. If I say the mass of the iron is 7 gram and its volume is centimeter cube. Of the iron is having mass 7 gram and its volume 10 centimeter cube. Now, the important points we are going to see. Okay, let's see that density is a factor which does not depend on shape and the size. Density doesn't depend on shape and size of the body. It means if the body's shape changes or size of the body gets changed, then there is no change in density. This is important. Second, all the substances we find expands, right? All substance expands on heating and contract on cooling. It means what? Here temperature increases and here I can say temperature decreases. This is our common experience that all substance shows expansion in them on heating, because due to the heating the kinetic energy of the molecules of the substance get increases. So the force of attraction between the molecule decreases and the intermolecular space then between these molecules increases. Means the volume increases. As we know, density is mass upon volume. It means as the volume increases, density decreases. So here we find density decreases of the substance which expands on heating, and the density of the substance increases as it contracts on cooling. Okay, so here I can say that all the substance expand on heating and contract on cooling. In the contraction we know that the temperature decreases, and due to decreasing temperature, force of attraction between the molecules of the substance increases. As it increases, intermolecular space decreases. As it decreases, then its volume decreases. Okay, so they start contracting, expansion. The force of attraction in expansion decreases. Okay, intermolecular space increases, and in case of the contraction, intermolecular space decreases and force of attraction increases, right? So these things you keep in mind. All the substances expand on heating, while all the substances near about contract on cooling, but some exceptions are there. So one exception which we are going to study is water. Okay, what is the nature of water? As we start heating the water from 0 degrees Celsius to a 4 degrees Celsius, then it shows contraction. Actually, here we find rising temperature, but still water shows contraction. Okay? And above the 4 degrees Celsius, if we raise its temperature, then it shows expansion. Means again behave like as a remaining substance. Means increasing temperature shows expansion in the substance, which we discuss here. But in this specific range, means 0 degrees Celsius to 4 degrees Celsius, water starts contracting. Okay? So this is very important point. So this is whole about the density. So question, define density first. Second, state two factors on which density depends. Explain how. Explain how. Now, for this question, I am going to give you answers. State the two factors on which the density depends. What is density? Mass upon volume. So, first point is that mass, right? We find here that density and mass are in direct proportion. There only I explained it. So, as mass increases, density of the substance also increases. But you don't have to write like this. What you write? As mass of substance increases, then density of substance also increases. And second point is volume on which it depends. As volume of substance increases, density of substance decreases. Means here you can keep in mind as mass is directly proportional to density, and density is inversely proportional to volume. Here you say density is directly proportional to mass. That is okay. It is. So this is the answer for this. More question that you solve this first and this third also. State SI, CGS units of density and deduce relation between them. Okay, उनके बीच में जो रिलेशन आएगा SI और CGS यूनिट का वो भी आपको निकालना है. Okay, so this much is sufficient for a day. In the next grade, when we again meet, then we will see the next topic related to this chapter, physical quantities and measure. Okay, I am going to call you after every 15 days for notebook checking. So in the next week, I am going to call you for notebook checking. You do to write in the notebook. If I do not find your writing in the notebook, then I am not going to give you internal marks. And you know well that 30 marks for the first semester, 30 marks for the second semester is in my hand as a subject teacher. So these internal marks, if you want, then you have to write in the notebook. Understood? Everything. These points also and the supplied question answers also. Okay?